For our penultimate probability video, we're going to consider the ideas we've looked at already and how we can generate some formulae for them, which can help us to work out the answers to certain questions. The first one we're going to look at is called, colloquially, the addition formula. Now, what this is a formula that links the intersection and the union of A and B. Now let's think about the union of A and B for a second. I'm going to write here the probability of A or B equals. Now if I want the union of A and B, that means I want everything inside the circles. So I want all of A and I want all of B. But if I just add A and B together, I have a problem because I have counted the intersection twice and the union counts everything in the circles, but the intersection would only be included once, of course. So what we need to do is, because we've included the intersection twice, we need to subtract one instance of the intersection so that it's only included once. And this here, therefore, is called the addition formula. Now you can rearrange this however you want to, but I could make the intersection the subject, so I could bring the intersection over to the left, adding it of course because it's negative here, which means I would have to take the union to the right and subtract it. So both of these are rearrangements of the same formula. Let's look at it in action. The probability of A is 0.6, B 0.7, the intersection is 0.9, find the probability, the union is 0.9, find the probability of the intersection. Now, because we are asked to find the intersection and we know everything else in the formula, the addition formula, we don't need to worry about drawing a diagram, we can just jump to the formula. We can say that the probability of the intersection is the sum of the probabilities of A and B, but minus the probability of the union. So summing our numbers in, we've got 0.6 plus 0.7 minus 0.9, and that is going to be 1.3 minus 0.9 is 0.4. So the probability of the intersection is 0.4. Now, the other formula that you may find useful is the multiplication formula. And the multiplication formula links the probability of A and the probability of B with the probability of A given B. It also makes use of, well, it mainly makes use of the intersection, which you'll see in a moment. Now let's think about how we find the probability of A given that B has happened in terms of what we were looking at in the last video of restricting the sample space. If we are given that B has happened, that means that we reduce our sample space just to the B circle. So I'm only interested in this bit here. None of that is applicable, none of that, only interested in that. So what that means is we know the denominator of our fraction is the probability of B because of restricting the sample space to B. Now within that, we are then interested in the probability that A occurs. Now A occurs only here in that circle. Now if we think about the whole diagram again, the section that I've dotted is the intersection of A and B. So now we have a formula, if we need it, for finding the probability of A given B, and that's the intersection of A and B over the probability of B, the second one. And it comes directly from the idea of restricting the sample space. Now, I can rearrange this by multiplying the probability of B up to the other side. So I could say the probability of A given B multiplied by the probability of B is equal to the probability of A and B. So let's look at this one in action. We are told that the probability of C is 0.2, D is 0.6, and C given D is 0.3, And using that information, we are asked to find a few things. First of all, what's the probability of C and D? So let's have a look. Do we have enough information to use this formula here? Well, the probability of C and D would be, think about it in place of A and B here, it would be the probability of C given D, and you have to make sure those are the correct way round, multiplied by the probability of D. Whichever is the second letter here is the one that you'll use there. So we have the probability of C given D as 0.3 and D is 0.6. So we've got 0.18 using our multiplication formula. Now, in the next bit, we are asked to find the probability of D given C. So yeah, let's use the original version of the multiplication formula. So that's the probability of D and C over the probability of the second one. So the probability of D and C is the same as the probability of C and D, so that's 0.18, over the probability of C, which was 0.2, so 0.18 over 0.2 is 9/10, or 0.9. And finally, in part C, we're asked to find the union, C or D. So let's use the addition formula from the first part here. It means we add together the probabilities of C and D, but we subtract the intersection. It's not A, it's C. It's better. So 0.2 add 0.6 minus 0.18. So that's going to give us 0.62. So now you know enough to have a go at exercise 2D.